In this session, we are going to talk about one of the most trending topics that we have today, which is energy and sustainability, right? As we know that we are going through various challenges, especially here in Europe from energy crisis perspective, but throughout the world, right? Energy and sustainability has been top of mind for our customers, especially in the enterprise sections, where they have their own sustainability goals in the next 10 years, 15 years, 20 years. And everybody would like to get to carbon neutral in the next 15 to 20 years. And so we have a lot of opportunities here. As we look at the future of work, and as we look at the smart building, digitized workspaces, one of the things that we have to look at and see is what is the opportunity here for the network. And I think we have a lot of opportunities here from how we can optimize the energy in our workspaces, in our smarter buildings, in our digital buildings. And network is really the catalyst to drive this transformation, right? Network is really the catalyst to drive this transformation of energy savings. So, and that's where we see convergence of IT, OT, data, and energy. And I think we have an opportunity here to bring sustainability goals for our customers. We can help our customers in 3 key areas. Number 1, power over Ethernet. We know that network has had power over Ethernet for quite a bit of time, but in the last few years, we have standardized the 90 watt. What does that really mean? That means that now we have a lot more endpoints that can get connected to the network, and that can help with the IT-OT convergence. So that's the first one. Power over Ethernet is also energy efficient and cost efficient, directly or indirectly. But we can definitely bring cost savings for our customers with PoE power. And we are seeing these trends. The ecosystem is expanding, and we are seeing a lot more endpoints getting connected to the network, be it a light, blinds, HVAC systems. There are a lot of things that are starting to get connected to the network. And it is really translating into intelligent energy savings. So that's number 1. Number 2 is class 4 circuits. Class 4 circuits that enables high voltage up to 450 volt DC power in a touch safe environment. And it's really touch safe because Andrew has touched it and he was just fine. So,
part of it.
All right. But really, this is happening now, today, and that's where we have an opportunity to bring energy efficiencies, because the transmission of energy with high voltage DC is much better than the traditional power sources. And that's where our own devices can save energies, because we can power our own devices with high voltage DC, and we'll show some of those new devices that we are bringing today. And the third is visibility-driven energy savings. So if you have better visibility in your environment, you can make intelligent decisions. If you know your occupancy, if you know your energy consumption through the network, through the sensors around in the smart buildings, you can make better decisions to power up the HVAC at the right times, for example, power down the lights, bring up the blinds. So it gives you energy savings, and it gives you better environment, better workspace. And so these are the 3 areas where we are going to talk about in a little bit more detail. We are going to show you some real-world examples on how Catalyst 9000, switches and access points, and Cisco Spaces is helping a lot of these buildings, the new smarter buildings, save energy and helping our customers get to their sustainability goals. So with that, I'll hand it over to Andrew, who is going to walk us through some of the details.
Hi, my name is Andrew Liu. I'm the EM Product Manager Lead for Sustainability and Smart Buildings. Coming in, it's important to realize that smart buildings is not like a very simple solution, right? It's a full stack of technologies to enable this wide selection of use cases, right? At the bottom, we have WebEx, Cisco, Meraki, and with all the different IT and OT endpoints. In the middle, we have Catalyst 9K with PoE to actually supply both power and data to the endpoints. And then there we have Cisco Spaces to provide you visibility into your space utilization. And on top of that, we have large selections of building management system partners that we work together with them to automate your entire buildings. And of course, there are other operational partners to basically supply technologies such as PoE lighting, blinds, and the other places of the building. But the important part is that at the center of this, we have a converged network enabled by Catalyst 9K. Now, what are the things that we're connecting here, right? Muhammad talked about 90 watt being a really important advance in that technology, because in terms of daisy lighting, how a lot of this lighting can be deployed is now, instead of putting one lighting per port, we can actually now daisy chain up to 3 LED lights per 90 watt port. That actually is really important in the economies of the lighting subsystem. And this makes it actually very viable, sometimes even better than your conventional AC mains lighting in terms of CapEx cost. And we'll talk a little bit more about that later. But there are, of course, other endpoints that we're connecting as well, the various sensors, Wi-Fi switches, light switches, as well as HVAC controllers can actually be connected and powered by PoE. On the software side, we're talking about having a kind of IoT gateway that basically sits on the app hosting capabilities in the Catalyst 9K, right? So that you can actually talk and translate all the inputs coming from various sensors and actuators, as well as having a local traffic filtering, as well as local logic happening all on the switch, so that in case a uplink is lost, you can still perform certain functions. And all of that goes into Cisco Spaces, and via our Firehose API goes to additional ecosystem partners that does the building automation.
Yeah, so does that mean that you need storage on your Cat 9K switches?
Yes, some storage, yes. So it's important to remember that the hosting part on the Cat 9K for the smart building deployment is a convenient place, right? But also you can actually somewhere on the part of the network to host it somewhere else, right? And typically the traffic that goes through a lot of these OT endpoints are very small. We're talking about kilobytes per device, right? So the actual requirement for the system is very low.
Yeah, I'm just thinking if you have a lot of Cat 9K switches around, like let's say a couple of thousand, and you need storage in each of them, it's a different license cost.
So to give you an idea, right? We have a customer who's doing, I think, a 4 storage unit, entire lighting based on Cat 9K, and the data throughput of that month is 800 megabytes. And so basically that requirement is really, really small. And these are, of course, some of our flagship smart buildings. All of these have Cat 9K as the Cat 9K PoE as enabling infrastructure. We actually do have a showcase session for Pen 1 in the World of Solution. I encourage everyone to actually go see it, check it out. And I think we also have a virtual reality tour for Penn 1 as well. So definitely a good experience. And for the, let's say, in-person tour, we do have also the Bishop Gates in London. That's a little bit closer of a flight to Europe. You guys are definitely also encouraged to go check it out. But also it's important to realize that smart building is not just about building brand new stuff, right? It's a journey that our customers can actually choose to start whenever they want, and going from something as small as a room refresh and to something, of course, quite as grand as new buildings. And Cisco has the experience working with all of these customers at different, let's say, life stages of their building and their smart building journey. But let's now switch gear a little bit to talk about the actual benefits of smart buildings, especially from an OT and sustainability kind of perspective. OT meaning, of course, operational technology, right? We group this under 3 big pillars. Number 1, smart environment automation. Number 2, it's a safe DC power source. And number 3, it's a converged and centralized architecture. And we'll talk about the benefits of each and every one of this. So with smart environment automation, right, this is actually how typically a customer would manage their OT resource in a building. We're talking about this is basically the control of ventilation in an actual customer's space, right? The blue shades means that the ventilation system is on, and the blank space, of course, means it's off. Now, with the waves over here is the actual occupation data of the building. So right off the bat, we're seeing like you have a lot of mismatch, right? In the morning, people come in pretty late for some of the offices, but you have the HVAC turning, you have the ventilation on full speed. And then, of course, during the after hours, some employees will actually work pretty late, but your HVAC is actually off. This also leads to below average, let's say, user experience, right? By actually connecting or automating your HVAC system to, in response to your actual occupancy data, which means in this case, compressing some of the blue squares a little bit and shifting some of it to the right to actually correspond to the actual occupancy of the building. Typically, you are able to achieve energy savings for the entire building in the range of 3 to 5%. And in addition to that, if we add variable visibility and control, meaning if I can see the occupancy in each different individual rooms, and I can control the actuators like HVAC, like lighting for each individual rooms, that will actually add to additional savings, sometimes go as high as 12%. And on the right-hand side, so just to show you that this is not just like theory, right? On the right-hand side, we have the actual monitored energy consumption for Penn 1. If you remember, that's one of our flagship offices, right, in New York. On top of that, on top of the chart, the blue line is the actual OT power consumption. And on the bottom, the orange line is the actual IT power consumption. And the dotted line is without like changing your building management according to occupancy data. That's probably where your OT power consumption would be. And then you can see the actual measured line. And with the spaces, you can argue that the spaces in between would actually be your savings in terms of power, right? And this goes so granular. You can see that between the dates, November 22 and November 26, that's actually the week of Thanksgiving in America. You can see some lazy people are starting slacking, not showing up in the office in the very beginning of the week. That's why it's a lot lower than the rest of the week. And then by the end of the week, everybody just checked out, right? So having this kind of capability and having that level of granularity in terms of visibility and control can lead to tremendous savings for the customers.
Couldn't the graph show something different? Because I think the blue dotted line is what you think it should be, right? Or what you think it would be. But probably if there's no one at the office, things will go off. So the actual line would be different as well. It's not that it would be flat
no,
on top.
so the dotted line is what would have been if you don't have all this smart automation. But the blue line is the actual consumption. So we are already implementing all these automations and monitoring, and that's the level of results or the level of savings that you can actually achieve.
Just a quick question. The type of data that's feeding into saying if the person is there or not there, what kind of data do you bring in? Because I know I've worked in many offices where the lights have just gone off and then I have to walk around trying to find the sensor. I'm hoping there's more than just that.
Right. So over here, like on the OT side, we have the PoE lighting, shades, HVAC, and also smart desk. All of these feed into the OT line, and then of course it's not necessarily everything in the office, but I think this represents a good chunk of the overall spending. And of course, shameless plug for Cat 9K here, that because we are, yeah, the other part that we are actually working towards is that in the future we want to make the IT portion actually also proportional to your occupancy data as well. But that's a long-term goal. Right now there are a lot of technical restrictions that we can't do that.
So one question out of curiosity, and maybe totally out of place. You provide infrastructure to build these kind of solutions, these smart buildings, but do you have some kind of software to orchestrate all of that, Because it's kind of complex if you think about the inputs you need, thermals, the light, biodynamic lighting and stuff like that. So is there a way you can manage that somehow?
So we actually have partnership with a lot of major building automation systems, so building management system like Siemens, Schneider, Honeywell, Johnson Control, right? In Cisco's position, you'll see that we actually consciously made a decision to only be the provider to the visibility, right? And to actually pull the controls is actually going to be our building automation partners who already, let's say, manufacture a lot of these endpoints and actuators.
Mm-hmm. And the follow-up question to that as well, this is very much focused on large enterprises, big office spaces and so on, but are you seeing maybe something, maybe with what you do with Meraki eventually, bringing that into, smaller size buildings? I'm thinking about things like, of course, as an individual, I'm thinking about what I could do in my home, right? And also thinking about schools and things of that kind, right? Because maybe it's a better way to standardize, let's say, some kind of home-grade PoE switch and bring all of these things rather than to rely on consumer-grade lights and things like that, which are somehow dependent on some ecosystem like HomeKit and things of that kind.
Yes. So that's actually a very interesting question. In terms of route to market or the end customer, of course, we do have smaller customers that basically rent, let's say, an office in a bigger building. But that building is managed and owned by someone, right? And our initial step is actually go to that person to say, let's revamp the entire office, and we can offer you all these savings in terms of energy, and that's how we actually go to market for now, right? But eventually, do we have a more, let's say, democratized system, like each individual can actually set this thing up in their house? I want to say that's a good long-term goal, but we're not quite there yet.
So just to understand it correctly, the software to tell a device or to tell a Cat 9K switch to turn off or turn down the power is made by someone else or you guys?
It's the BMS, building management system vendors. Yes. We have the capability to turn things on and off, but we choose to actually work with them because it's the entire ecosystem is actually quite complex in terms of endpoints and also automation. And they have the expertise and are probably the best entity to actually take on the responsibility.
Yeah, I was just thinking about the school example. If you have a large school and you have several thousand access points, well, you do have the telemetry and the data to actually know is anybody in this building, and you could tell DNA Center or something like Spaces to shut down the access points until somebody appears on the security camera or something like that. So I guess you have some kind of intelligence for doing it.
And that's, I think, that part of the capability, at least on the access point side, I think it's something that we're already working on.
Yes.
Right? So that through DNAC, you will actually be able to do a lot of automation and coordination. But we also realize that not all smart building customers actually will have DNAC. But most of these customers will have an existing building management system vendor that they're working with.
Are you working with those kind of vendors to individually, or are you trying to make an open framework that anybody can tie into?
So right now it's like peer-to-peer integration. I think long-term wise, we'll have to see where the chips fall at this point.
Yeah, I think I'll just quickly add one thing here is we are in the first stage of this, right? Where we are getting visibility from the network itself. Like we are using intelligence from the access points, for example, on occupancy of these spaces. And Cisco Spaces take that and give you the intelligence of what is the occupancy right now, right? So just talking about the occupancy. From there are open APIs that our partners ecosystem can utilize and do various things using their building management systems, right? So that's kind of the first step where we are, where the network is providing you the visibility. I think the next step, natural step, is how can we control, right? There are two parts to it. One is the OT pieces and how we are going to control that. And the second is the networking devices themselves and how we can optimize energy within those. Both of those things, I think on the OT side we're a little bit probably ahead because our partner ecosystems are already working on it. On the IT side, we are starting to work on, and we will bring those control points from some platform, right? This could be a DNA center, right? So that's where we are. Just wanted to kind of clarify a couple things here.
I have also a question. I have worked with several vendor, let's say, building management system from a different angle, from security angle, yeah? And sometimes from a security perspective, it's pretty wild what they are doing, yeah? And they have a lot of open things, not patched for years, or not even the capability in patching. So besides this energy aspect, are you also thinking with the technology that you have to secure these building management networks better, make sure that they not get hacked? Because if it is smart, if it has an IP connector, it can be hacked, yeah?
Yes. I think at Cisco, we're developing everything with security in mind, right? But of course, security is maybe.
Yeah. So you guys might have heard about endpoint analytics as part of our overall DNA center and SD access story. That endpoint analytics brings really the OT security, because these OT devices, a lot of time, they don't have a whole lot of intelligence. We cannot run an antivirus system on that, right? This is just impossible. Yeah. And so you really need another system, and that's a separate topic. I'm not sure how much time we have here, but I think endpoint analytics is the solution at this point, which can really enable security for these not so intelligent endpoints that we have out there.
Yeah, I think with analytics, with visibility, everything starts, yeah? I think if you come up with kind of guidance, because these building management networks are they are not security minded, they are not security focused. So I think that could be a good cooperation if you come up with standard design to make this a bit more secure. Yeah.
Very good point. Yeah, absolutely.
But as of today, because security is a discipline and it is a practice, you do see. Oh, okay. You do see different levels of practice, let's say, within the OT community about how they handle security. And I think for us, the point is when they're ready to come to really ensure the security of the infrastructure, we are ready for them. Okay, maybe I'll probably talk through this a little bit more quickly. The Cat 90 watt PoE portfolio, the second pillar of our benefit is that it's actually a safe DC power source. Safety is really important, and it's also what actually adds to a lot of the cost of deployment, right? So we found out that because PoE cables are actually inherently safe, this can actually often lead to up to 10% CapEx savings, even with the cost of the switching devices calculated in taking into consideration, right, versus your regular mains or AC technology. And also DC infrastructure is a lot more efficient with renewable resources because your solar and your wind typically comes to a DC source first, and has to be, if you are running your grid, you're running your building on AC power source, then you have to be converted to AC first and then back to DC to supply to all your appliances. And that typically is a 20-25% energy waste, right? If you run a DC infrastructure, which PoE actually is, you got to save a lot on the efficiency part. And of course, okay, now is the time for the shameless plug. The Catalyst 9K series actually does have the industry's densest 90 watt ports, which allows you to actually spread the cost of the switch to all the different endpoints and make it a very cost-efficient solution. Right? We can quickly jump through some of these. These are the platforms that's more commonly used for your smart building deployments. And the emerging technology that we're seeing now in the United States, not quite come to the Europe yet, is Class 4. What it is actually a new standard of power limited circuits that's already codified in National Electrical Code 2023, so it's already in there. It is touch safe, ground safe. It can be transmitted up to 450 volt DC, and it's actually not limited to 100 watt as PoE is. The benefit of this is, of course, higher transmission efficiency. It's a DC microgrid alternative, and it has all this building safety. So a lot of that savings from not having to take extra safety precautions actually is also captured by this technology. Today, how this is deployed is that you have a FMP server that actually talks to a receiver in Class 4 circuitry, and then from that receiver, you'll break out to 380 volt DC that's not touch safe, and that can be basically connected, feeding to a switch, and the switch does the last mile distribution into all these endpoints, and the last mile is touch safe. So we've replaced, let's say, 2 out of 3 segments in your building circuits, making that touch safe. Only 1 small segment remains, right? So that's definitely an interesting technology to look out for.
As well as being more sort of efficient with the power transmission, do you get any kind of distance gains as well using the higher voltage?
Exactly. So this typical transmission range is with, I'm sorry, I have to go imperial here, but with the 18 gauge wire, which is very commonly used for lighting, you can have a reach up to 2 kilometers. And the transmission efficiency is typically very high, in the high 90% range.
What does this mean for the networking teams within a company, because they have something else that they need to address as admins? And secondly, what about redundancy? So how are they going to make sure that the lights stay on, that everything keeps up and running with this all running on the switches as well?
So from the networking equipment part, and I can give you my personal take, is that 380 volt DC is going to be more of a common power standard. You already see that in the data center side, right? Even in Cisco's own product portfolio, we have 380 volt DC power supplies coming out. So that should be relatively quick. In terms of redundancy side, that actually has already been addressed by the switching, right? So how you do your wiring in the ceiling, all of that actually helps address the redundancy part. The power actually doesn't have to come into, doesn't have to affect this. Okay, another shameless plug here is that our Catalyst, we are also launching our first high voltage DC compatible switch here. That's our compact switch. All right, one last point is that by using the Cat 9K as your smart building infrastructure, you now have a centralized converged infrastructure. We're not talking about IT/OT convergence. We're talking about data and power convergence. Think of how that will actually enable you in terms of management and also debugging, right? And troubleshooting. Anything goes wrong, you can actually control everything at one point. What also happens is now you have a centralized architecture, where it means all the failure-prone or not so durable parts are now aggregated in one place. If you have to replace them, it's easy to find. You don't have to actually take a ladder, go around hunting the failed parts under the ceiling tiles.